Today's podcast will be on thermochemistry by Lindsay and Christina. So for today's podcast, two equations are going to be most important. As you look at the phase change chart, there are three spots where it increases, and that is called heated up. And there are two spots where it stays the same, which is break it up. So the equation for heated up is a well-known one. You've probably seen it in class. Q equals mc delta T. And the equation for break it up is Q equals delta HN. So in each equation, the M stands for grams. The C is specific heat, and the delta T is change in temperature. And for break it up, delta H is heat of fusion, or there's certain ones for like water, so heat of fusion or solidification. And the N stands for moles. So this equation is probably newer at this moment, but if we go back to the phase change chart, A to B here and here would all be heated up, and these would be break it up. That's when you would use the certain equations when doing calculations. One thing that's important to know is that Q is equal to kilojoules. So when you go for calculating either one of these, you have to know that up here it equals joules, but you want them to be the same. So either this has to go to joules or this has to go to kilojoules, so that they can be in the same calculation when you have to add them up at the end. And we'll explain that later. But for C, one example of specific heat is 4.8, which is liquid water. Our first example is going to be a heated up problem. Our question asks, how much energy does it take to warm 28 grams of water from 8 degrees Celsius to 61.2 degrees Celsius? So we're going from about here to here. We're going up in liquid. So the first thing we're going to do is, it's a heated up, so it's Q equals mc delta T. So after you have your equation, Q equals mc delta T, you're going to fill it in. So first, we already have grams, so Q equals 28 grams. Your next is specific heat. It's liquid water, so we talked about how it's 4.18 for specific heat, and that is joules per grams degrees Celsius. And then your last part is your temperature. So you're going to have to subtract 61.2 and 8, and you're going to come up with 53.1 degrees Celsius. And you're going to want it in degrees Celsius. And then you're just going to put this into your calculator, and you will come up with 6226.5, and that is joules. And if you wanted to go to kilojoules, it would just be 60.2 kilojoules. You can put the decimal point over 1, 2, 3 places to get kilojoules. And that's all you have to do for heated up. Say it again. So example 2 is going to be just break it up. And in this problem, we are going to go from here to here. So we're using this whole point. So our question is, how much energy does it take to melt 70 grams at its freezing point of 0 degrees Celsius? And the first thing is to break it up. We know that the equation is Q equals delta HN. And we know that N is moles. So 70 grams is going to be turned into moles. So So we know there's 18 grams because it's water and 1 mole, and that is going to come out to 3.88 repeating moles. Okay, so the next thing that we're going to want to do is find that delta H is H fuss, which is 6.01. It's a constant, it's known, it's on your charts. Alright, and then we're going to fill in the equation. So Q equals 6.01 kilojoules per mole times 3.88 moles, and that, we're going to put that right into our calculators. I'm going to do 8, 9 to round up, and I'm going to do times 6.01, and my answer is going to be 23.37 kilojoules. And if we want it to be joules, we move the decimal point over 3 spaces, 1, 2, 3, so it's going to be 3370 joules. And that is how you do a break it up. So example 3 is from the question, how much energy does it take to warm up 20 grams of water from negative 30 degrees Celsius to water at 70 degrees Celsius? So we go back to our phase change chart, and now we're going from about here in A all the way up to C about here. So we're going through 3 changes. We're going to go through a heat it up, a break it up, and then a heat it up. So our first heat it up is going to be an MCAT, because heated up is MCAT. So Q equals MC delta T. So we're going, and remember, we're going from negative 30 degrees Celsius to 0 degrees Celsius, because this part is where you hit 0 and you're going to go 0. We're going to go from a solid to a liquid. So right now we're in solid to 0 degrees solid. Okay, so both of these are solids. And then we're just going to fill it in. So it's going to be M is going to be 20 grams. This is Q equals. And then ice, the specific heat of ice is on your chart. It is 2.09. And that is going to be your joules per grams degrees Celsius. And finally, you're going to put your temperature in, which negative 30 to 0 is 30. So, and then degrees Celsius, and then you're just going to put that in your calculator. And so I'll do that right now. So we've got 20, 2.09, and 30, and we are going to get 1,254 kilojoules. And that is the first part. So this is actually joules on our last answer. So now we're going to do our break it up, which is Q equals delta H N. Alright, so now we're going from 0 solid to 0 liquid. And we're just going to fill in our equation again. So we are actually, it's going to be moles, so 20 grams divided by 18, 1 mole, comes out to 1.11 moles. So we put 1.11 in the equation, and then we find that 6.01 kilojoules per mole is the H fuss, and that comes out to, let's see, we put 1.11 and 6.01 in our calculator, and that comes out to 6.611 kilojoules, which we want to be joules, so 1, 2, 3, 6, 6, 7, 1 joules. And now we found the second part, which is the shift between here and here, which is a break it up. For the last part, we are going to go from here to about here. So we are going from 0 degrees liquid to 75 degrees, as said in the question. So our first step is we have to remember we're going from 0 degrees liquid to 75 degrees Celsius liquid. And our first step is we have to know that we're doing an MCAT. Q equals MCAT, so we're going to fill it in like we did before. 20 grams from the equation, or from the question. 4.18 is water. We have the specific heat of water now because we're a liquid. And finally, our temperature from 0 to 75 is 75. So then we can put that in our calculator and we get 6270 joules. Now, here comes the ending part where, because we have 3 different parts of the phase change, we have to add them up. So I'm going to add them up. They're all in joules. So we've got 1254 plus 6671 plus, so I'm getting, these are my final answers, 6270, and I'll press equal, and that will be 14195 joules. And if I want that to be kilojoules, I go over 1, 2, 3. That'll be 14.195 kilojoules. And that is how much energy it takes to warm up 20 grams of water from negative 30 degrees Celsius to water at 70 degrees Celsius. That's it.